Okay, Mrs. Gray and Jeter here, and let's walk through some problems of everything that we have learned so far about factoring. So, looking at here, remember, if we are given a multiple choice problem, you can always work backwards, meaning you can always just multiply, right? Every answer choice to see if what you get is up here. So that will definitely work. But we're gonna just take a look at factoring this. So the first thing we're gonna do is look at your coefficients, okay? Look at your coefficients. Do your coefficients have a greatest common factor? Well, yeah, they each can be divided by 3. So the first thing is I know I can take a 3 out. Now I'm gonna look at my variables. Well, they each have one x in common, and they each have one y in common. So the first thing I'm going to do is I am going to factor out a greatest common factor of 3xy. So I'm going to divide all of these by 3xy. And now when I do that, 18 divided by 3, that's 6. If I start with x squared and I take out one x, I'm left with an x and a y and a y. I have no more y's left. Now my middle term, negative 3xy divided by positive 3xy just gives me negative 1. And my last one, 6 divided by 3 gives me a positive 2. If I start with an x and I take out an x, I'm left with no more x's, and a y squared, take out a y, I'm left with y. And there is my answer with greatest common factor taken out. Here is this next one. Okay, this is one we can look at two ways. So first, we can play Xbox here. Okay, meaning we can identify our A value, our B value, and our C value. Well, my A value is always attached to that x squared, so that is 16. My B value is always attached to an x, singular x. Notice there's none there, so that one's 0. And my C value is 36, and then you can play Xbox, okay? The other way is, well, when I look at this problem, what do I notice? Well, one, I notice that the B value equals 0. The second thing is when I look at my A and C, I notice that they are perfect squares, okay? And then my third is that both of those are connected by subtraction. So in my mind, I'm thinking, do I have a difference of squares? Well, yeah. So remember, difference of squares, just take the square root of both sides. Square root of 16 is 4. I'm left with 1x. Square root of 36 is 6. And the difference of squares says one of my factors will be a positive 6, and one of my factors will be a negative side. And you would have gotten this the same way if you would have just played the Xbox. So here's one. We're going to do Xbox on this one. Here we'll identify our A value, our B value, our C value. Notice our A value is equal to 1, our B value negative 1, and our C value negative 12. So we're going to play Miss Gray's Xbox. Remember up top, A times C. We know A times C is negative 12, B is negative 1. So now we need to find two factors that will multiply to give us negative 12, but will add to give us negative 1. So I know 4 and 3, didn't mean to do that quite yet. 4 and 3. One of those has to be negative because I have a negative on the 12, a negative on the 1. Okay, now I'm not done yet. Remember, I just found those middle terms. Those are my B values. I can only do this when my A value is equal to 1. I'm simply going to split my X in 2. And I'm going to plug in what I got here in the middle. So one of these is going to be a negative 4. One is going to be a positive 3. And remember, we can check it by just multiplying it back in. X minus 4. X plus 3, so we're left with x squared minus 4x, 3x minus 12, and then pull it out of the box. X squared, I'm left with negative x, and I'm left with negative 12. Okay, here's my next one. On this one, my A value is greater than 1. But still I'm just still going to play Xbox A, B, and C. A is 9, B is 48, C is 64. So here, let's see, I'm going to have to do my A times C equals my B. My B value is 48. I am going to have to go into Desmos for me. I need to know my A times C value, so 9 times 64. Wow, that gives me 576. So you need to find two factors that will multiply to give us 576, but will add to give us 48. And here I have 24 and 24. Okay, I found that with Desmos. So now, here's where it's different. My A value is greater than 1. So I'm going to write my first term, 9x squared, my last term, plus 64. And then I'm going to just add these two terms in the middle. So I have plus 24. I need to add an x to it, plus 24, add an x to it. Remember, if I were to add both of these together, whoops, they give me that middle term, right? They're giving me that middle term. Now I'm just going to split these. I'm going to group them together, and I'm going to take out the greatest common factor. So 9x squared plus 24x. Well, I know they have a 3 in common, and the greatest common factor is an x. So if I divide 9 divided by 3, I'm left with 3x. 24 divided by 3 gives me 8, and I'm left with no x's. Now look at my second group, 24x and 64. They have a positive 8 in common. So 24x divided by 8 is 3x. 64 divided by 8 is 8. And here are my two factors. I know I'm on the right path because my parentheses match. So I'm left with 3x plus 8. And what I take out is a greatest common factor, 3x plus 8. Ah, they're both the same. So we're going to write this in even simpler form. Okay. Since 3x plus 8, 3x plus 8, they're both the same, it's simply going to be 3x plus 8 to the power of 2. Okay, so let's see which expressions are equivalent. So remember, when we have answer choices like these, we could work backwards. Okay, so meaning just multiply. But I'm going to take a look. 6, 12, and 18, well, they have a positive 6 in common. So I'm going to factor out a 6, meaning factor out the greatest common factor. I'm left with x squared minus 2x minus 3. Well, there's one. And now, well, I'm going to play Xbox here. So -3, -2, two factors that will multiply to give me -3, but will add to give me +2. And now I'm going to split my A value. I have x squared plus x, -3 plus -3, or -3x plus -3. Okay. And now I'm going to take out the greatest common factor. Well, I can only take an x, and so I'm left with x plus 1. I will take a -3. I'm left with x plus 1. So one of my factors is x minus 3. The other factor is x plus 1. And then remember, at the very beginning, I took out this 6. There is my other factor. So this is a question from our District 3 question test. So let's go ahead and review it. Remember, it's multiple choice. You could have worked your way backwards, meaning you could have put each answer choice into the box and multiplied it. I'm just going to factor it here. My A value is 1. My B value is -3. My C value, -28. And here we go. So I need two numbers that will multiply to give me -28. Remember, because this is my A times C. and add to give me -3. So I know my two factors, -7 and +4. Now, because my a value is equal to 1, I can simply split my x into two separate binomials. And I know one of my factors is x -7. The other factor is x +4. And we can check it by putting it back into the box and multiplying it. And here is my next one. Once again, I'm going to do my a value, 16. My b value is -40. C value is 25. I'm going to play Miss Gray's Xbox. So up in the top, it's a times c, which gives me 400. My b value is -40. So I need two numbers that will multiply to give me a +400, but will add together to give me a -40. So this is a -20, -20. Now my a value is not 1, so I cannot split that 16t squared. Instead, remember, I'm going to write my first term, 16t squared, my last term, plus 25. And I'm going to fill in the middle here. So I have -20t, -20t. Remember, we do that because if I were to add both of these together, I'm getting my middle term. Okay, so that's the whole point there. Now I'm simply going to group both of these, and I'm going to look at them as individual binomials. So between 16 and 20t, what do they have in common? Well, I could easily factor out a 4 and a t from each of them. So I'm going to put 4t, and then 16 divided by 4 is 4. I'm left with 1t. -20 divided by 5 is -5, and no t's left. Now I'll look at my next one, -20t and plus 25. So here I can factor out a -5 from each of them, meaning they can both be divided. So I'm going to take out a -5, and I'm left with 4t, and 25 divided by -5 is -5. I know I'm on the right track because my parentheses match. So this is one of my terms, 4t minus 5. My other term is the greatest common factor, what I pulled out, 4t minus 5. Oh, they just happen to match, so I'm going to rewrite this as 4t minus 5 to the power of 2. Okay, so here is my next one. So first I'm going to take a look and see if there's anything that 3, 8, and -16 have in common. If they do not, okay, so I'm going to do my A, my B, and my C. Now this particular problem, you do need to know how to factor, because notice it's asking which expression is a factor. I can't get myself out of it by multiplying, so you have to know how to factor. So I'm going to play Xbox. 3 times -16 is -48, and I need a +8. So I need two numbers that will multiply together to give me a -48, but add together to give me a +8. So that's going to be a +12 and a -4. Okay. Now my a value is not equal to 1, so I cannot split it. So I'm simply just going to write my 3g squared and my -16. Okay. And now I'm going to take what I got into the middle and plug it in here. This is where you need to be a tad bit strategic. So look at the 12 and the -4. Which one do you believe is going to go better with the 3g? Well, I'm going to put in my 12g. And then -4g is going to go better with 16. So now I'm going to split these in two. And I'm going to look at this first, 3g squared and 12g. Well, each of these can be divided by a 3g. So I'm going to take out the greatest common factor of 3g, so I'm left with g plus 4. My next is I have negative 4g and negative 16. So they both have a 4 in common, and because this leads with a negative, I'm going to take the negative with it. So I'm going to divide this by negative 4. So I'm going to take a negative 4 out, and I have g plus 4. I'm pretty confident I'm on the right track because my parentheses match. So I have g plus 4 as one factor. My other factor is what I took out, 3g minus 4. And now looking at my answer choices, C is it. Okay, this is just a quick review of a warm-up we did the other day. The graph of a linear function passes through the points negative 4, 0, 2, comma, negative 6. What must be true? You could just plot the points on two Desmos. Okay, it tells us the slope is negative 2, so you could find the slope by that y2 minus y1 over x2 minus x1. The y-intercept is negative 4. So remember, key feature, y-intercept. Y-intercept means there's an x value of 0, and to be the y-intercept, it has to be 4. Well, I don't see a point like that. The 0, another name for 0 is x-intercept. Key feature of x-intercept is the y value is 0. So the x-intercept would look like this, and lo and behold, that's one of my points. So this is my answer. The last one is we're looking at law of exponents. So first thing is we're going to look at our coefficients. Remember, coefficients we treat like coefficients. They do not follow law of exponents. So if we have 4 over 8, can that be reduced any more? Absolutely. That's nothing more than 1 over 2. So now I'm going to deal with my y's. The bases are the same. So I'm going to say the quotient of power rule that says if the bases are the same, here the bases are the same with y, I keep the base, and when dividing, I subtract the exponents. You have to be careful here. So I'm like 7 minus, but listen, this is a negative exponent right here. So 7 minus negative 2, right? We know the double negative turns into a positive. I'm left with 1/2 y to the power of 9, or you can write that as y to the power of 9 over 2. Okay. The other way that you could have done this is you could have done the negative exponent rule first. Okay. So here I have 4y7. How do I get rid of the negative exponent? Well, I send it upstairs. The coefficient is staying down at the bottom. There's nothing wrong with it. But to make that y positive, I'm sending it up top. Okay. Product of power rule that says if the bases are the same, add the exponent. So I'm left with y to the power of 9. And then I am just going to simplify 4 over 8. I know 4 over 8 simplified is 1/2, the same thing. I hope that this has helped.